All right. So today, instead of focusing on long division, which was Friday, we are going to focus on what's called synthetic division. Synthetic, you've probably heard that word before, and that means man-made. That's what synthetic means. So here's what happened. Somebody was doing long division, and they said, wait a minute, I see an easier pattern here. I think if I just did this, it would be a lot easier. And it turned out it worked. I mean, it's just a really easy, nice pattern. So where we were at was right at the top of a page that started with synthetic division. Right here. Simplifies that long division process. Definitely simplifies the long division process for dividing by a linear expression. So here's a highlighted piece right here. Dividing by a linear expression x minus a. So what does that tell us? We can't use it for everything. We couldn't go back and use this for those problems in yesterday's assignment that had numbers in front of the x. If it said divide by the quantity 2x minus 1, we wouldn't be able to use this simple new method that we're going to get today. So what they're saying is the reason we showed you long division is because long division works for everything. It does. Long division is going to work for all of it. But for some of these, some of them, if it doesn't have a number in front of the x, say you're dividing by x plus 3, you could do this an easier way. You could do it with the man-made way, the synthetic way. So to use synthetic division, here's what we do. We write just the numbers, the coefficients, but you have to make sure you include anything that's missing. You put a 0 in if there's no x squared there, all that good stuff. You write that in standard form like we're used to. Again, zeros and anything that's missing. Don't put the variables in. Don't put the exponents in. For the divisor, if we see this as what we're supposed to divide by, we're going to use 3 for a. Now that we're used to too, because we've been finding zeros for a long time. So what we're really doing is thinking of this like, we're going to be doing zeros. So if it's x minus 3, we know a would be 3. That would make it work. Now what does this allow us to do? It allows us to do some of the problems that we did yesterday very quickly and easily by just doing two things. Two things that most of the time we don't need a calculator for. Add and multiply. If you think back to elementary school, adding was the first thing you learned. When you got done with addition, you were like, oh, this is great. We should do this forever. I love adding. This is so easy. And then they said, here's subtraction. Subtraction was a little tougher. That's because it uses a different part of the brain. It's a little backwards thing. Then you learn your multiplication table inside and out. They're giving you those tests and saying you have 3 minutes. Boom, go. And you got 100 problems and you're whipping through them like crazy. Remember that?
So fun. So fun.
And you said, got this. Don't teach me anything else. If we could just spend the rest of our life doing this math, I got it. And then they said, here's division. And you said division, not so much. Don't like the division. So today what we're going to focus on is a process where you just add and you multiply. But I will need your full attention, and in order to do that, and because it's math magic, I have to put on my math magician, my math fairy outfit. I cannot teach math magic without my math fairy costume on. I need my tutu. My tutu on here. I need my wings. You can't be a math magic fairy without wings.
Morning.
Put the phones down. And a tiara.
Nailed it. Oh my God.
And my magic wand. Because I'm going to show you math magic. So, away we go. Here it says, use synthetic division to divide x cubed minus 14x squared plus 51x minus 54. Now, I noticed it's in standard form and nothing is missing. I also noticed that's a linear factor. That is in that x minus a form. So they told me if I want to do the x minus a form, I'm supposed to think of this like a 0. So if it was x plus 2, it would really be a negative 2 that would make this work. So when it's in that format of x plus or x minus something, we have to change the sign. Now, that's going to go up front, just like our divisors did before. Going to go right out front. And what we're going to do is we're going to put a little kind of half box around it. And then we're going to draw a line. And that's because division needs a line. I mean, we do that with division. Works out right. Now, here's what we do. This is why this becomes so easy. We're not going to take all of this mess right here. We're only going to take the numbers. As long as it's in standard form and nothing's missing, we're just going to take the numbers. If anything's missing, we put a 0. So we have 1x cubed, negative 14x squared, 51x, and negative 54. Those are the numbers that we have to work with. Now, synthetic division is a process of adding and multiplying. So, you know, you have those lines off to the side on your paper there. Here's what we're going to do. We're going to write down inside the box, add. Outside the box, multiply by a. And this always alternates. So we're going to go inside the box, then outside the box, then inside the box, then outside the box, then inside the box, and outside the box. So inside the box, add. Outside the box, multiply by a. This is the box, right here. Now I say that because there are some books that actually, instead of this line business, do an upside down division symbol instead. So it's kind of a box when you do that. And I actually like that notation a little bit better. But this book says, put the negative 2 in the little box and just draw a line. So think of this as one big box. You ready? Now, the point is, the math is not going to be hard. It's add and it's multiply. That's all we have to do all the way through this. But we need a place to start. Well, we have this thing called a leading coefficient. Leading coefficient is where we should start. It leads. So we're going to bring this 1 right down here. Notice it was inside the box. Now it's going outside the box. If I'm outside the box, I'm supposed to multiply by a. This is a. So 1 times negative 2 is negative 2. And I was outside the box, so now I have to go inside the box. That's where my negative 2 goes. Now I'm inside the box. Once I'm inside the box, I have to add. Negative 14 plus negative 2 is negative 16. Now I'm back outside the box again. When I'm outside the box, I have to multiply by a. Negative 16 times negative 2, that's 32. And now I'm inside the box. When I'm inside the box, I'm supposed to add. 51 plus 32, that's 83. Now I'm outside the box again. When you're outside the box, you're supposed to multiply. So 83 times 2 times negative 2, negative 166. I'm inside the box. And I add. Obviously, it's going to be negative. Let's see what we have here. 0, 11, 12. Negative 220. Okay, so you're home. I like that. Adding, multiplying, all good stuff. But that doesn't look like any of the answers I wrote down on yesterday's assignment until you do this. You always start over here. Remainder, constant, x, x squared, and if there were another one, we'd do x to the third, x to the fourth, x to the fifth, etc. This is our answer. We just need to know how to write it. This is going to be 1x squared minus 16x plus 83 minus 220 over x plus 2. There's our answer. And we didn't have to do any long division. Ta-da! Or should I say abracadabra? There it is. Math magic. Awesome. I wish we could use this for everything. We can't. We can't. If we went back to yesterday's assignment, we could use it for a lot of them because there were a lot of them that had linear factors, but not all of them. So long division is what we'd have to use for those. We need some more practice. Let's do this one. Use synthetic division to divide x cubed minus 57x plus 56 by x minus 7. Here's what I'm doing when I'm reading the problem. I'm looking to make sure that this is that x minus a format, because I have to do that for synthetic. And then I'm thinking to myself, okay, then a would have to be 7, because it's going to be x minus 7, a is 7. So I need a little 7 out here. The next thing I'm checking for is the problem in standard form? And even if it is there anything missing? There is. We don't have an x squared this time. You have to put a 0 in for that or it won't work. So 1x cubed, 0x squared, negative 57x, and 56. So what we're really doing is we're going back up here and saying, uh-oh, there wasn't an x squared. Now, synthetic doesn't work if any of them are missing. And here's a mistake a lot of people make. If there's no number in the back, you have to put a 0 in that last position. You have to. It has to go all the way down from the top power to the very last constant. So if anything's missing, you do a 0. Alrighty, let's see how we can do it this one. How do you start? Bring down the 1. Leading coefficient starts it off. You're outside the box. What do? You do. You put it inside the box. Now you're inside the box. What do? Add. Remember, it's add and multiply. So what do I now do with that 7? By 7, put it inside the box. Add them. Multiply. Wait a minute, we didn't get a 0 last time. What does that mean?
No remainder.
Excellent. There's no remainder. It divides perfectly. Remainder, constant, x squared. There's our answer. X squared plus 7x minus 8. Ta-da! So whenever you write it, you have to get rid of the x's and add it. Yes. It's like we don't need them to do the math part. But to write the answer, they've got to go back in. Yeah, exactly. Oh, love synthetic. Magic. It's absolutely magic. All right, you ready?
Nope.
Nope. This looks like a word problem, right? It's not. There's a picture. It says the polynomial x cubed plus 7x squared minus 38x minus 240 expresses the volume in cubic inches of the shadow box right there. They want to know what are the dimensions of the box. And that means the length and the height or depth as they go through this. There you go. Colin found it.
Nailed it.
Down here. X plus 5. Well, volume works this way for boxes. It's length times width times height. We have to take that x plus 5 out of there so we can see what's left. That's division. So we're going to divide this by x plus 5. So, what should I put in this little box? Good, negative 5. It has to be negative. Is it in standard form? Sure. Anything missing? Nope. All right, so we've got 1x cubed, 7x squared, negative 38x. It's negative 240. Now here's what I know in advance. It's going to give me a remainder 0. If it doesn't, I did something wrong because they're telling me it was here. That was an answer. So let's see what we get. How do you start? Bring down the 1. Then inside the box you add. Outside the box, multiply. Inside the box. Guess what negative 48 times negative 5 is? 240. That had to happen or we knew we did the math wrong. They told us that was one of the factors. It's down there in the picture. So what do we have left? Remainder constant x squared. So here's what we need to do. If we're going to find the other 2 dimensions, we just need to factor this. It's not a perfect square trinomial, obviously, with the 48 back there, negative 48. No, remember this last one is always the remainder. So remainder constant x squared, x cubed, x to the 4th. It's always remainder, then constant, then x is increasing from the right-hand side. Can you give me 2 numbers that multiply to negative 48 and add to 2? Now, their hint was, if we really want to know which one is length and which is width, it says the length is bigger than the height or the depth. Well, the one that's adding is definitely going to be bigger than the height or the depth. So the length is x plus 8. Do we have any units on here that say inches? It was cubic inches, so this is inches. So inches for both of us. Looked like a word problem. Not a word problem. Has the formulas right there for us. Has picture, for goodness sake. It's not a big deal. All right. This one says, what if the width of the box is 15 inches? What would the other 2 dimensions be? Oh, well, that doesn't sound like a big deal. This was the width. Our little x plus 5. So they're saying, what if you actually measured it and it came out to 15? What would x have to be? It would have to be 10. And if we know that x is 10, could we figure out the length and the depth? Of course we could. 10 plus 8 is 18 inches. 10 minus 6 is 4 inches. Ta-da! You know, little bit of algebra, that's all that is. Synthetic is a dream. It is a dream. Got it. 4 says, if the polynomial x cubed plus 6x squared plus 11x expresses the volume in cubic inches of the box, and the width is x plus 1 inches, what are the dimensions of the box? What's going there? Careful. -1. Is it in standard form? Anything missing? You do your synthetic, I'll do mine. We'll see if we all meet up at the same place. Take a peek when you're done. Looking good? So let's write down what our answer is at this point. Remainder constant x squared. So that's what we have left. And they want to know if we broke this up into the other 2 dimensions, what would they be? It's not a perfect square trinomial, so we'll just go to old-fashioned factoring. What should we use? 3 and 2. So we'd have x plus 2 inches and x plus 3 inches. And there it is. Notice how this kind of started us off so we could factor. Synthetic division helps a lot with that. So if we can at least figure out something to do synthetically, then after that, it'll become a lot easier. Now, there's something else that we used to do that we had to do with a calculator in the past that we may not want to do with the calculator anymore. The remainder theorem is going to help us provide a quick way to find the remainder of a polynomial long division problem. It says if you divide a polynomial p of x of a degree where n is greater than or equal to 1 by that linear factor, then the remainder is p of a. Now that looks like absolutely nothing, I know. But here's what they're saying. That last number that you get as your remainder is what you would get if you evaluated it for that number. That means when we had big long polynomials before, and I said, find p of 3, you were grabbing a calculator and you were putting in 3 to the 4th minus 7 times 3 cubed minus 8 times 3 squared plus 7 times 3 minus 15, when all along, we could have just done this synthetically, and we would get the same answer. It absolutely happens. So they've got a, here's why it works down here, and what it shows is, if we are doing this division, and we say, you know what, I'm going to put a in this slot. Well, if we did that, that would give us 0. So this part would be gone, and all that's left is the remainder. So the chimp there's picking his nose because we didn't know synthetic existed, so we couldn't do this before. This is a duh moment. My goodness, we're going to get an answer here. So down here, given that p of x equals x to the 5th minus 2x cubed minus x squared plus 2, what is p of 3? Is that in x minus a format? So we don't have to change the sign. It's only when it's in an x minus a format that we have to change the sign. We're going to put 3 out there. But this one we have to be careful. Something's missing, isn't it? So we've got 1x to the 5th, but 0x to the 4th, negative 2x to the 3rd, negative 1x squared. Uh-oh, we're missing an x. And then we have our 2. Move my little x minus a here. Sorry, Haley, I was...
There you go.
Yes, if anything is missing, bless you, even that last number, you put a 0 in. So let's put a 3 into this monster function and let's see what we get. If we bring the 1 down, oh, you know what? You go ahead and do yours and I'll do mine and we'll see if we all meet in the same spot again. Everybody there? Take a peek when you've got your math done. This is our answer. That is our answer. Not the whole thing. They didn't ask us to divide. It said, find what you would get if you put 3 into this function. That's what we just did synthetically. This is not called synthetic division anymore. This is called synthetic substitution, but you do exactly the same thing. We're saying if we took this 3 and we put it into each one of these slots for these x's and we did the math with our calculator, we would get 182. We absolutely would. In fact, I'm going to show you, just so everybody believes me. Let's put a 3 into that little monkey and see what happens. 3 to the 5th minus 2 times 3 to the 3rd minus 3 squared plus 2. 182. But we didn't need a calculator to do that. We can just do this synthetically. Very cool. All right. Ta-da! Let's go. Oh, the gridded response thing, they're not doing this anymore. They used to do this on the MCAs. And yeah, supposedly it's going to be all multiple choice. But just in case, everybody listen up because this is important to your MCA score. Our answer was 182. Now, you can put 182 all the way to the left. Fill in the little circles. The computer will mark it right. You can put 182 over here and fill in the little circles. And the computer will give you the points. You do 182. You've got the right answer, but you put it smack dab in the middle. It won't count. It'll say it's wrong. So if you see gridded response on your MCAs, be very careful to either put your answer all the way to the left or all the way to the right so that you'll get your correct answer counted. I know it's weird, but it's a computer glitch. That's just what happens. All right, let's look at this one. Still talking about our synthetic division. Again, the other name for it is synthetic substitution. Given that p of x equals x to the fifth minus 3x to the fourth minus 28x cubed plus 5x plus 20, what is p of negative 4? Do we change the sign? No. This is not x minus a. We're going to do a negative 4. Again, because this is not x minus a format, you just use the number. We missing any stuff this time? What's missing? Missing the x squared. We're going to need a 0 there. So 1, negative 3, negative 28, 0, 5, and 20. It's a little bit longer one, but the numbers aren't horrible. So why don't you go ahead and give it a try while I'm doing this up here. What does this mean the answer is? 0.
Circle.
I had to stop myself from putting my little box around my answer up there because I wanted to make sure everybody knows. When we're doing this, what we're saying is if you put negative 4 into this equation, you will get 0. That's right? Right there. Okay. Coolness ratio, this is like pure, you know. This is very cool stuff. It is math magic. And why do I wear this costume? Because it's math magic, but also because you don't know how many times I've gone through this whole process and nobody knows add inside the box and multiply outside the box. But I wear this and everybody looks up here and takes attention. So it works. What you do. All right, 4, 3, 2, 1, 0 me. How do you feel about synthetic division, synthetic substitution? Oh yeah. Adding and multiplying, you guys are like, got this. Excellent. Excellent. Do remember, we can't use this all the time. I wish we could. You can't use it if there's a number in front of the x. You can't do it. So keep that in mind. You'll probably have at least one in your homework that you have to do with long division. It's not going to work to do synthetic. Woo. That is good stuff. So get cracking on it. Oh, this goes so fast. You guys might finish this before you leave. Crank it out.